Hey guys, so we're back for another week, getting there. So today we are going to continue our work with functions, but for this week we are going to be talking about linear functions. And as we learned last week, those are functions that will result in a straight line. All right, so let's get started. Okay, so I want you guys to think about this question for a minute. Which graph could represent each situation? Hold on. All right, so if I had a graph that is just continuously going up, and then I have one that's continuously going down, and then I have one that is laying flat. So the length of a line you draw with your pencil over time. So if I'm drawing a line, would you guys agree that the longer I draw my line, or sorry, the more time that goes by, the longer my line would be? I agree with that too. So let's say that this is the length of the line, and then this is the time. That means, or actually, these would be reversed. But either way, as the time as the time increases, so does the length. All right, the length of your pencil lead as you use it over time. I think we can all agree that if this is time, and then this is the lead. So you start writing right here, and then as time goes by, though, wouldn't you agree that your lead gets smaller and smaller because then eventually you have to sharpen your pencil. And then if you don't use your pencil, the lead stays the same or constant. So those are just some kinds of things to think about. So real world situations, that would be a linear function. Okay, and we've already talked about a linear function is a graph that makes a straight line. So the only one here that would be a linear function is y equals x plus 4. And again, it has a constant slope. It makes a line. Absolute value functions, we haven't talked about those yet, but that is not a linear function. It makes two straight lines, but a linear function makes a continuous straight line. And as we already talked about last week, a vertical line is never a function, or it's not a function, so that means it's not a linear function because it's not a function, period, because vertical lines would not pass the vertical line test. Okay, function rules, they would have a slope and a y-intercept, as we've talked about before. When we talk about slope and intercepts, those make a straight line. Things that are not a function or linear function would be anything with absolute value, exponents, or down here, if the x is in the denominator, that is also not a linear function. If x is in the denominator, it can be in the numerator, it cannot be in the denominator. All right, let's take a look at these. So we already said y equals x squared is it's not a linear function, or I should say nonlinear, because it has that exponent. Anything with an exponent is nonlinear. Y equals 4x, yep, that would just be something increasing by a multiple of 4. Y equals negative 3x, yes, would be linear. 8 over x would not be because the x is in denominator. X minus 2, yep, we have a slope of 1, a y-intercept of negative 2, so that would be a big yes. All right, let's keep moving. Okay, so finding function rules, we've done this before. We're looking for our y-intercept, or our starting point, and then we're going to count the slope, which is the up and over, or the y over x. All right, so let's take a look at what that looks like. So I have a line here, and we know our starting point is 0. So we're just going to add a plus 0. We're not going to need it, but I just want to make a point. And then to go to my next point, I go up 1 over 1. So that would be 1 over 1 x plus 0. I want us to think about that for a minute. 1 over 1 is just 1. Plus 0, we don't need that. If you're adding 0 to something, it doesn't matter. If you guys think back to last year, that's the identity property of addition. 1x would just be x. So this is a y equals x line. Here I have a slope of 0. I'm going down 1 over 1, so we know it's a negative slope of negative 1 over 1, and then it's still a plus 0. That 1 over 1 we can get rid of, so this would just be y is negative x, or the opposite of x. And you can see that here, if x is 1, y is negative 1. They're opposites. All right, let's look here. We still have a intercept of 0. Our slope is going to be up 2 over 1. So this is going to be y equals 2x, because that's our slope, plus 0, that's our y-intercept, which is just going to be y equals 2x. All right, what is the function rule for this graph? I have a starting point or an intercept of negative 3. So we know it's going to be something minus 3. And that something is going to be our slope. I'm going to put my x here because we know the x is going to go there. Here's my next point, and we go, actually, this is my next point. We go up 1 over 1. Up 1 over 1. So this is going to be y equals 1x. And we don't even need that 1, so it's just x minus 3. All right, which equations represent linear functions? This kind of went out of order. This should have been with the other stuff. If I rewrite x over 2, this would be the same as 1/2 times x. And the x is in the numerator, not the denominator. So yes, this is linear. This is not linear because we have an x in the denominator. Again, exponents and x's in the denominator will never be linear. Y equals 3x would be yes, because we have a constant rate of change of 3. All right, let's keep going. All right, a swimmer burns 8.8 calories per minute while swimming laps. What function rule describes how many calories the swimmer burns? If I did this out, so this would be the minutes and the calories. So after 1 minute, it's 8.8 calories. So after 2, we would double that. So that would be 17.6. And then we would keep going. So basically, each time we are increasing at a rate of 8.8. So be the number of calories is 8.8 times the minutes, or 8.8 per minute. All right, last thing. Matt is 3.5 years older than Sam. What function rule describes Matt's age any given year? So we know that Matt's age is 3.5 plus Sam's age, because he's older, so we're adding to Sam's age. Let's put a M for Matt and an S for Sam. So this would be M is 3.5 plus S. So if Sam is 10, Matt's 13.5. If Sam is 11, Matt is 14.5, and so on. All right, and that is it for today. Again, it's kind of a quick review. I will be, you guys are going to head to the Pearson now, and then I will see you at Zoom at 10 o'clock if you have questions. And I miss you guys a lot, so I hope to see you on Zoom. I like to see your faces every now and again. All right, bye guys.